Hello, today we will be talking about rebuilding the forest, succession and resilience at Point Pleasant Park after Hurricane Juan, presented by Sarah Taubman, Kaylin Power, and myself, Roman Joseph.
When Hurricane Juan, a Category 2 hurricane, made landfall in 2003, it caused catastrophic damage in Halifax, Nova Scotia. At Point Pleasant Park, over 70% of the tree canopy was uprooted, and because of safety concerns, the park remained closed for 8 months while debris was cleaned up. Point Pleasant Park is a 75-hectare urban Acadian forest located on the southern tip of the Halifax Peninsula in Halifax, Nova Scotia. It is important to recognize that Point Pleasant Park is located within Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. The site was traditionally a significant place gathering known as the Amnumagi, known as the Place of Spirits. However, this disturbance created an opportunity to study its forest regeneration and succession in the most impacted areas of the park. Ecological secondary succession is the gradual change in species composition and forest structure following a disturbance such as a hurricane. By examining patterns of secondary succession in Point Pleasant Park today, we can evaluate how the forest has changed over the past 2 decades as it is in a mid-successional stage. Our study aimed to understand how Point Pleasant Park's forest has changed in the 2 decades following Hurricane Juan. Specifically, we wanted to determine whether the forest is recovering towards its pre-hurricane condition or shifting to a new ecological state. Our null hypothesis states that there's been no significant change in forest composition following the hurricane, specifically that the densities of red maple and red spruce, as well as overall species richness and diversity, including Shannon's diversity, has not changed over the 21-year period, and any observed differences are assumed to be due to random variation rather than succession. We hypothesize that the park has undergone secondary succession and is currently in a mid-successional stage. We expect to see changes in species composition and diversity that reflect gradual recovery following the hurricane. To test these hypotheses, we compared post-hurricane data about its forest composition and diversity. These metrics allowed us to assess patterns of succession and ecosystem recovery.
This study was conducted in Point Pleasant Park, also known as Amdugadi, Halifax, Nova Scotia, in the Acadian Forest region. 6 permanent 20-meter by 20-meter plots were established in 2004 in areas that experienced the highest levels of disturbance after Hurricane Juan. In each plot, all living trees with a diameter at breast height, DBH, greater than or equal to 2.5 centimeters were identified and measured with a diameter measuring tape. DBH is measured at 4.5 feet off the ground. Species density was calculated as the number of individuals per 400 meters squared plot. Annual density data collected between 2004 and 2025, excluding years with missing data, those being 2004, 2005, 2007, 2016, and 2020, were analyzed using linear regression to assess long-term trends. Linear regression analysis was chosen because it allows for the detection of directional changes in species density over time. Since time is a continuous dependent variable, linear regression is a good method for detecting directional trends across multiple years of data.
I'm going to talk about how the overall forest community changed over time and why, and what we can predict will happen to the overall community as the forest moves towards its climax community, and why. When we looked at the total density graph, we can see that the tree density has clearly increased over time. The regression shows a positive slope of about 7.9, which means the forest is gaining roughly 8 trees per 400 square meters each year. The p-value is extremely small, so this increase is statistically significant. The R-squared value of 0.45 tells us that about 45% of the change in tree density can be explained simply by the passage of time since the hurricane. We found this with our hypothesis that the tree density increased significantly from 2004 to 2025 due to the recovery after Hurricane Juan. Also, the null hypothesis is that there was no significant change. Any differences were just due to random chance. Ecologically, this makes sense. After Hurricane Juan in 2003, about 70% of the trees were destroyed. This created open canopy gaps and allowed more sunlight to reach the forest floor. With more light and space, new trees were able to grow. This is an example of secondary succession. Based on this trend, I will predict that the density will continue to increase in the short term. However, as the forest moves towards its climax community, growth will slow down and density will stabilize. As trees get larger, competition for light and nutrients will increase, and some trees will die. So density won't keep rising forever and it will eventually level off. Overall, the data shows that the forest is recovering and progressing through secondary succession.
How has the density of the dominant species in 2004 as well as the dominant species in 2025 changed over time, and what we can predict will happen to the dominant species as the forest moves towards its climax community? So the density of two dominant tree species, red maple and red spruce, were tracked from 2004 to 2025. Red maple, an early to mid-successional species, increased rapidly over time with 2.24 trees per 400 meters squared per year. This is because it thrives in high-light conditions created by the hurricane's canopy gaps. In contrast, red spruce, a shade-tolerant late successional species, increased more gradually with 0.35 trees per 400 meters squared. Its growth is favored as the canopy closes and light availability decreases. To evaluate these trends, the following hypotheses were tested. We hypothesized that red maple, an early to mid-successional species, would increase rapidly in density following the disturbance because of its ability to establish in high-light canopy gaps, and the null hypothesis for this was that there will be no significant changes in the density of red maple between 2004 and 2025. Our second hypothesis was that we predicted that red spruce, which is a shade-tolerant and late successional species, would increase more gradually in density over time as canopy closure progressed. The null hypothesis is that there will be no significant change in the density of red spruce over the 21-year study period. Based on these trends, we reject both null hypotheses and can predict that as the forest moves towards its climax community, red spruce will eventually become dominant. This is because it performed better under the low light conditions of a mature canopy, while red maple's growth slows once the canopy limits sunlight. Overall, the forest is transitioning from an early post-disturbance stage to a mid-successional stage, moving gradually towards a late successional Acadian forest. Human activities and park management may influence these patterns, but the natural progression of succession is clearly visible. Integrating indigenous ecological knowledge, like the Mi'kmaq principle of two-eyed seeing, could further support the forest recovery by combining scientific monitoring with long-term stewardship practices.
How does species richness change through succession? To address this question, I analyzed species richness as an indicator of forest biodiversity and community structure. I tested the null hypothesis, which states that there's been no significant change in species richness over time, to evaluate whether the forest is undergoing measurable succession. The p-value of 2.6 times 10 to the negative 18 is extremely small, so we reject the null hypothesis and conclude that species richness has significantly changed since the hurricane. Figure 1 shows the relationship between species richness and time in years, with a regression slope of 0.57 and a slope of 0.48. This indicates an increase of 5 trees per 400 meter square plot over time, and this explains that new species are colonizing the open spaces created by Hurricane Juan, demonstrating ongoing forest succession. Additionally, 58% of the variation in species richness is explained by Hurricane Juan over time, showing a moderately strong pattern of new species colonizing the forest over the past 2 decades. As the forest moves towards its climax stage, species richness is predicted to plateau, reaching the site's natural limit, because only a stable set of species adapted to the area will persist. How does Shannon's diversity change through succession? Shannon's diversity measures both species richness and how evenly individuals are distributed among them. I tested the null hypothesis that Shannon's diversity at Point Pleasant Park hasn't changed since Hurricane Juan. The p-value of 1.4 times 10 to the negative 8 leads us to reject the null hypothesis, supporting the alternative that significant changes have occurred. Figure 2 shows Shannon's diversity increasing steadily since 2004, with a slope of 0.0555 per year, and an R-square value of 0.3262. This indicates overall biodiversity is increasing, where species are relatively balanced and no single species dominate. About 33% of variation in Shannon's diversity is explained by Hurricane Juan over time. As the forest moves towards its climax stage, Shannon's diversity is expected to remain high, reflecting a balanced community where species coexist more evenly and no single species dominate, resulting in a stable forest.
To conclude, looking at all of our data, I would argue that Point Pleasant Park is currently in the mid-successional stage. Tree density has increased, which shows the forest is still recovering from Hurricane Juan. However, the average DBH has decreased, meaning most of the trees are still relatively small and young. This tells us the forest hasn't reached a mature, late successional stage yet. Looking at biodiversity, both species richness and Shannon diversity have increased. This means more species are establishing and the community is becoming more complex over time. Evenness has stayed fairly stable, which suggests dominance patterns are still balancing out. When we examine species trends, red maple has increased significantly. This makes sense because it thrives after disturbance. Red spruce is also increasing, which is important because it's characteristic of mature Acadian forests. However, it's not dominant yet, which supports the idea that the forest hasn't reached its climax stage. It's also important to remember that Point Pleasant Park is an urban park. Succession isn't happening in a completely natural way. Assisted planting may speed up recovery, while invasive species and heavy foot traffic can affect soil conditions and competition. So the forest is recovering, but human activity is shaping that process. From a management perspective, applying the Mi'kmaq principle of two-eyed seeing, or itupa tumubuk, could strengthen recovery. This approach combines scientific data with indigenous knowledge about long-term balance and relationships with the forest. Instead of focusing on only increasing tree density, management could aim to restore a truly resilient and stable Acadian forest. Overall, the evidence supports that Point Pleasant Park is in the mid-successional stage and still progressing toward a mature forest community. To answer this question, although Halifax did not experience a major hurricane this year, the province faced drought and wildfires that temporarily closed Point Pleasant Park. To make forest ecosystem more resilient to wildfire, management could focus on increasing species diversity and maintaining more native, fire-resilient trees. Reducing fuel loads by removing dead wood and thinning overly dense areas would also help lower fire intensity. Restoration efforts could aim to create a mixed-age forest and control invasive species, both of which improve overall ecosystem stability. Indigenous knowledge can also play an important role. Practices such as cultural burning, which involves low-intensity controlled fires, have traditionally been used to reduce fuel buildup and maintain healthy forests. Applying the concept of two-eyed seeing, we can combine scientific approaches with indigenous ecological knowledge, and that could support more resilient and sustainable forest management in Point Pleasant Park.
Some key factors beyond tree density that should be emphasized to help move towards a mature biodiverse forest are vertical and horizontal structural diversity. A resilient forest needs multiple canopy layers. This supports diverse niches for wildlife and plants. And fallen logs and standing dead trees. These provide habitats for fungi, insects, and amphibians, and these also help recycle nutrients back into the soil. Some recommended restoration practices include enrichment planting, where if some climax species aren't returning naturally, they can be planted by the red maples to kind of speed up the successional transition, and invasive species management. Post-disturbance sites are vulnerable to invasive plants like Norway maple or European buckthorn, and active removal of these species ensures that the soil won't be degraded and that native Acadian species don't get outcompeted.
Is it possible that change in Shannon's diversity may be on a stable slope or lower in a late successional environment due to the increase in density following succession, increasing competition between species? Yes, it is possible that Shannon's diversity may stabilize or slightly decrease in a late successional environment. As forest density increases during succession, competition for resources becomes stronger. This competition allows more species to become dominant, which may slightly reduce evenness and cause Shannon's diversity to level off or fluctuate around a stable value. However, overall diversity is still expected to remain relatively high because many species are able to coexist within different ecological niches in a stable ecosystem. So rather than continuously increasing, Shannon's diversity in a climax community is more likely to stay high and relatively stable, with minor increases and decreases over time. So yes, Shannon's diversity typically increases during succession and then stabilizes in a late successional forest as competition increases and the community becomes more stable. Thank you for listening to our project. I'd like to thank past ecology students who have collected all this data from Point Pleasant Park, as well as our professor and our lab TA for all their additional help.